In this video, I will briefly introduce you to how you can do overcast lighting close to scientific method. So close to the mathematical method. Although in Unreal Engine, the sky atmosphere, which is the main method of getting proper overcast lighting using physically based correct information, has a lot of arbitrary values. So you need to obviously understand the math of this, but I will simplify it by giving you a general guideline that you can follow when it comes to doing this. Now, what I'm going to do first, I'm going to quickly implement the general numbers, and then I will explain the logic behind it afterwards, rather than doing it first. This is mostly to give you a quick visual understanding and the process of it, while I generally talk a little bit, and then I will kind of give you a bit more information. Not too much in depth, because of course it takes a lot of time to do too much in depth, and I do have paid courses for that. So for the directional light, I'm going to go to 30,000 lux, okay? And it's becoming bright. And it's using auto exposure at the moment to adjust it back down. Now 30,000 lux is a good value for an overcast day. Now the reason I know it obviously is two reasons. It's experience and also how Unreal Engine 5.5 works, but also because I have measured real life lighting in different environments similar to this one, and I kind of know 30,000 lux is the correct amount. I'm going to scroll down, and I'm just going to make it infinite so it affects the whole environment. And I'm going to go under exposure. I'm going to go here. I'm going to turn it off because I don't like to manipulate exposure compensation. And I will turn this on just to turn this off so the camera isn't doing anything. And then for min and max, I will simply add on the 30,000 lux to get a good exposed image. Which we often have to do when do photography, you will end up with like 13. So I will just, for this example, I will scale it up like this. Now, when you look at it, you go, well, that doesn't look overcast. Well, this is why you're watching this video, because I will show you how you can make it look proper despite not adjusting these settings that most people would do in other courses or other tutorials, which is physically incorrect. Okay. So that's the two settings. Now, I will also, from experience, just create 512 cubic resolution, and I will do the intensity scale a bit higher because we want obviously to have a little bit of good starting point of how the light actually works in the environment, right? It wouldn't be completely black. So let's start with 5 with possible adjustment that might be required. As that skylight is obviously affecting the sky, and you'll see what happens. Okay, so again, a quick recap. 30,000 lux is the intensity of the sunlight. It goes from 0 to up to around 120,000, and we want to make sure we're using physically correct values for this environment, which technically isn't lumen created, so I had to convert a little bit of it. Okay, the second thing is we're adjusting the skylight because it is quite arbitrary. There is no specific way of that I use yet to do that correctly necessarily. So the way to do it really correctly, and I mean really correctly, if I were to really give you more information, I wouldn't necessarily do it at the moment, but just I would measure it on a white surface, and I would measure the shadows and everything accordingly to get the correct ratio. But we are looking for flat lighting anyway, so that's why I'm skipping the process at the moment, as we're looking for not necessarily a huge amount of contrast if possible. But we can tweak that later. So with that said, I'm going to turn off the exponential fog because we want to get overcast lighting, mainly because of the sky atmosphere. Now, the thing with sky atmosphere, the top one has atmosphere, okay? So for atmospheric height, for an overcast day, I want to go higher up in the number. Now, why is that? Well, because the atmosphere height, it represents the vertical extent of the atmosphere where scattering occurs. So when the light hits the clouds and environment, it will scatter based on the height. So a greater atmosphere height allows for more scattering layers, and it basically enhances the diffusion of light and reduces harsh shadow under overcast skies. So I'm gonna put in 180 first, and you will see a little bit that kind of change at the back there happening. Now I'm not going in the right order that I would normally do. I'm just going down the list in this case. The second thing we want to change is the multiscattering. Now the multiscattering, it accounts for light bouncing between particles multiple times before reaching the ground. So obviously the more particles there are, more fog, dust, whatever, the more it's going to jump around before it reaches the ground. So here we want the higher multiscattering because it contributes to soft, evenly lit environment, typical of overcast lighting where light is scattered in all directions. So for this particular example, I'm going to go for 2. Now you might be going, but I don't see any changes. Again, because I'm doing this a little bit earlier to make sure that you can see the order of events. Okay, you can see it's being scattered around a bit more, which makes it a bit brighter. Okay, and now you might be going, okay, but what's next? Well, we're going to keep going the list. Now the thing with Rayleigh scattering is Rayleigh scattering scale involves smaller particles, so we're talking about air molecules scattering shorter wavelengths, which is blue light, right? And red being the longer wavelength, which is why during sunset, when the sun is lower down the horizon, you have more orange and red, because it survives the travel a bit longer than the shorter wavelength, which is blue. But in this case, a low scale here means Rayleigh scattering is minimal on the overcast skies, as the larger particles responsible for Mie scattering is dominating. So when we go down to Mie scattering, we're going to talk a bit about that as well. So I'm not going to change this at all at the moment. And I'm also not going to change the Rayleigh Exponential Distribution. This basically describes the fall-off rate of Rayleigh scattering with height. So basically the impact is that the higher values suggest that Rayleigh scattering decreases more rapidly with the altitude. This in this case has minimal impact in an overcast condition, because the Mie scattering is the one that's going to be the key setting here. So I'm going to keep that on normal. Now we come to the most important one. And I'm going to go back and up just so you can see the difference, because you might not understand otherwise. So with the Mie scattering scale, by definition, Mie scattering occurs when the light interacts with particles roughly the size of the wavelength of the light, such as water droplets in clouds. So basically, if it matches the blue wavelength, or the red wavelength, then that's when Mie scattering occurs. So the impact when you change this is a high value. It indicates a significant Mie scattering, causing light become diffuse and soft. So this is the main property of overcast skies, where clouds scatter sunlight uniformly. So from us, normally you could go 1, right? Now look what happened. It's already brightening the environment. So we didn't touch anything else. We simply started to understand sky atmosphere. I'm gonna go to 2, 3, 4, because I really want the fog to be closer. And when I say fog, remember, I haven't even turned on the exponential height fog. Right? I'm not depending on that just yet. That's just an added layer on top afterwards, which I don't necessarily touch too much if unless there's a creative reason, which in this case I'm not gonna focus on. Then you have a setting called Mie Absorption Scale. Now for the Mie Absorption Scale, it quantifies how much light is absorbed by particles instead of being scattered. Again, it's absorbing the light rather than being scattered. So when it comes to overcast, a high absorption scale means that the atmosphere absorbs more light. It will reduce the brightness and contributing to a more muted soft light on the overcast sky. So because of this knowledge, and I know that's what happens when you have overcast, I'm gonna slowly increase it just to show you what happens. Okay, look at that. You can have different overcast mood. I'm gonna go for a really dark one at the moment, because I already know that mathematically speaking, that's what I have calculated. Now the Mie Anisotropy scale I'm not going to change it too much, but basically what the anisotropy refers to is the directional preference in light scattering. So 0 basically means uniform in all directions. So it's basically spreading the light evenly everywhere, and it's not necessarily prioritizing the directional light. So if I do 1, it's gonna focus on forward scattering. So I'm gonna keep it at 0.7 because I want to have priority slightly towards forward scattering, but not as much as the original setting. So a value of 0.8 would indicate a very strong forward scattering, where light prefers to scatter in the direction it's traveling. This can also be used to create appearance around sun and also reduce contrast everywhere. So we're keeping it at 0.7 at the moment. Now you have something called Mie Exponential Distribution as well. Now this parameter describes how particle size distribution affects the scattering. So a value in this range suggests a balanced distribution of particle sizes, contributing to the effective light scattering and the even illumination typical for an overcast. So basically, if I go down to 0, there is nothing, right? Because there's no particle size distribution occurring. So I want to really make it like 1, 2, 3, and 3.5. Now it goes all the way to 20, I think, of 10. So this is not physically incorrect. This would actually happen when you have this much large particle absorbing the light and scattering it everywhere. So 3.5 at the moment is too much. I can see the sky. So normally I would go to 2.5, and the range I would normally use is 0 to 5, even though it goes to 0 to 10. When I calculate this, I'm calculating for the limit before the darkness. Now with the current setting, it's 3.5. Sometimes you can go higher depending on your settings that you have set up. Now, if you for some reason wanted to see the sky and the fog, you can also do this. Or maybe not that much, maybe you do like 0.1. You could also do that if you wanted to. For the time being, I will not do that, just to make it easier to explain some of the next things. Now, when you have overcast light, because the Rayleigh scattering still occurs, the reason we're not touching the sunlight anymore than we have, and not the skylight so far, which we might change depending on what we do with these settings, is we are trying to mimic real life. Now, real life overcast also has a little bit of blue at the back. Now, the way the Mie scattering works and the color works is that if I go to blue, it's gonna absorb the warm colors. If I go to warm color, it's gonna absorb the blue color. And I already technically revealed a little bit of how I do the Blade Runner lighting. So you can do the Blade Runner references the same way without doing any, if at all, very little cheating to get the look. So I'm just gonna slightly work my way so I have a bit of a blue muted tone. Maybe something like this. You can do the same for the absorption scale, which is you can use it also to create more creative lighting, like avatar, or I don't know, whatever you would think about. But for sake of this, I'm looking for a bit of a muted color, so I'm not gonna go too much. I'm gonna have a little bit around here. So you basically go the opposing color to absorb the color to create the color you need for your environment. Okay. So that's like the basic stuff that you can do so far. Now for the exponential fog, if you for some reason want to use that too, you can, of course. You can turn it on and you can see that it's just an added layer. You don't actually need it as much as you think if you do the sky atmosphere correctly. So this is more of a artistic reason, if anything. So normally you can play with it. So I don't know, let's go 0.2. That's maybe too much. 0.05 maybe. Yeah, it kind of goes over the environment. then 0.02, 0.1. Okay, so you can do what you need. I'm not going to explain that too much, as I assume you guys already know that. However, we want to turn on volumetric to get that more fog around. And I just want to explain the scattering distribution if you do choose to use exponential height fog, which obviously helps with getting that blue tint at the back. The scattering distribution in volumetric fog, it describes the angular spread of scattered light. So basically lower values will do isotropic scattering, while higher values indicates forward scattering. And as said, we are going towards forward scattering. Well, technically you don't need to, because it's overcast, so you could actually go for the opposing one. To be honest, you could go for like this, but let's just do 0.6. So a scattering distribution in this range would suggest some directional preference in scattering. I'm mixing a little bit up because I was doing Blade Runner, and in this case I would have gone for this one. And also for the extinction scale, which is here, the way it works here in relation to what we're trying to do is that the extinction includes both scattering and absorption. So it's basically describing the reduction of light intensity as it passes through the atmosphere. So a high extinction would be a significant light attenuation, which basically enhances the diffuse quality of light while reducing overall brightness. So if I start going to like 7, you can see it's basically bouncing around a lot. Because there's more particles around. Okay, so maybe you want to have like 1, 2, you know, it really depends what you're aiming for. Okay, so you can already see we are already getting pretty flat lighting. You know, it's starting to look like it's overcast. If I can do your thing, you can do your temperature, and you can add more mood to your lighting based on what you've done so far. You can add the torch lights, and you know, you already have an interesting scene, I suppose, if you were to do something like that. I guess in theory it would be more like this, I suppose. Whatever. And you could probably do a bit more subtle because it's torch. Right, so you would do something like that, you would adjust the color. Now, for the added tweak for these kind of things, you could also add a bit of bloom if you wanted to make it a bit more moody, and other things like noise and whatever. But as I said, you don't really need to do anything initially. So this is where you get creative and you do your tweaks as you need to. So hopefully that's useful. You have like a bit of an introduction on how to make the most out of this. So yeah, so this is what I originally was doing, and you can see it's more or less the same settings. Slight differences. Have a bit of a lower atmosphere height in this attempt. I have absorbing the colors both on different areas, turned down Rayleigh Scattering just to adjust it a little bit. And you can see I have tried more or less the same things, less drastic, a bit less picky on some of the settings here, but overall you could get the similar look as well if you needed for your work. So if I were to ignore this little setup that I did and just have a look. Oh yeah, that light shouldn't be there. I was showing someone how not to do it, so it would be more like that. Right, so these are all just the light, skylight, and then these are the fill light using from the actual drones basically. And as you can see, the whole environment is pretty foggy and overcast, and you know, there aren't really harsh shadows anywhere. And that's kind of what you want to do. You want to figure out what your references are and what you're trying to do. So this is basically, if you couldn't tell, based on Blade Runner as a reference. So again, using the same philosophy, I have used the sky atmosphere to do everything. Okay, so this is the neutral color. Even the sunlight, I haven't even adjusted the sunlight, which I probably could. And yeah, it's all color, light, diffuse, all comes from this setting, and that's what I'm trying to teach you here. So what I've done, I've converted the same knowledge, and the directional light, I believe I put on 70,000 lux, because I wanted to replicate a more harsh or bright light of a desert environment, and tends to be around 50 to 70,000 at the very least for that time of day. The color temperature, I haven't really adjusted the color temperature as I've been using the atmosphere, but if I were to do it using post-process, I would probably aim for 2000 to 3000. If I were to do a bit more than I have, I think I would probably go, instead of keeping it around this default range, I don't know, if I did that, you would have a more of this look. But the problem with doing heavy color grading should be obvious. Sorry, I should be the opposite one because of the white balance. But let me just do this. But the problem is if you do that, you end up with a bit of a different look. Okay, so there's not much happening there. So the most of the stuff that's happening, so if I just do this, it's not a big difference. It's just bloom. Okay, so what am I doing here? So again, I have the Mie Scattering. Let's go for the most important one. The Mie Scattering is on around 3. You could technically also do 4 on both. Basically, that would be to achieve a dense scattering effect and to simulate the dusty atmosphere. Okay. And the reason that I've kept to 0.8 is, again, I want to prioritize for scattering rather than evenly lit scattering. Okay, which at this moment is not as noticeable necessarily, but that's because I don't have some of the settings exaggerated, because that's not the reference I'm using. For Rayleigh Scattering, I did do 0.0.5. You could also go to 0.1, and that's because I want to add more atmospheric scattering, but I want to balance it to maintain the dominance of the Mie Scattering. So you have the Rayleigh Exponential Distribution, and it's set to a mid-range value for the same reason. Okay. For the Mie Exponential Distribution, I increased it to around, I believe, originally to 5 to 7. But because of the settings, as I said, over 5, it starts making it darker. So mathematically, I've decided to keep the range at 0.0 to 5. So that's why I ended up with 2.4. And the same with atmospheric height. I have it around 120 because I want to have a more confined atmosphere that mimics a dense dust layer, and for that you need to increase the height, as in real life. The multiscattering, I want to avoid over darkening the scene, so I increased it to 0.5. But if I went to 1.5 and put this on 5, this is where you kind of end up with similar math, right? So by using the combination of things and understanding what's darkening the scene and what's brightening the scene, you can actually light a complete scene by making sure that this is balanced. And as you can see, I'm absorbing a certain level of color. You can tweak it as needed based on your reference. And I'm also observing the opposing color here in this case, because obviously I'm looking to prioritize the orange color. As for the skylight, I believe I have it on 3 to make sure that, it's filling in the areas I should, and also brightening the sky, because if you keep it at 0, you would have to change the other settings. So sometimes it's just quicker to do this. Now this is the similar relationship between some of the settings I just showed you in sky atmosphere, but it's not necessarily physically correct. When I say physically correct, it is because you need to light the environment as if there was no fog around first, if you need to practice, and then you add the sky atmosphere settings and change it to simulate the fogginess, right? Because this is my argument. My argument is that when you have a daylight and it's overcast, the sun doesn't necessarily change, the sky doesn't necessarily change to the same degree. It's really the amount of particle altering your original settings, right? So once you understand how to manipulate the sky atmosphere, you will realize you can do more accurate lighting and creative lighting than before. So obviously, if you want a more completed, organized, more structured way of learning this, feel free to leave a comment, like, subscribe. I might put some more effort into explaining everything in more detail, different settings, different scenarios, so you can really understand it even more. But as for a free YouTube video, this is what I had time to do for you guys. I hope you enjoyed it and you got something out of this. And maybe you can try it out and let me know how it works for you. And thanks for watching.